Welcome to The Explainer, where we take complicated documents and turn them into stories you can actually understand. Today, we are unlocking the hidden language of the world's busiest airport, Hartsfield-Jackson, Atlanta. We're going to crack the secret code that keeps this massive place running like clockwork. Okay, let's just dive right in. What if the safety of your next flight depended on you being able to figure out this page? It's from the actual manual for the Atlanta airport. It looks like total gibberish, right? But believe it or not, every single letter, number, and symbol here is a critical piece of information for a pilot. So yeah, it looks like a secret code, but don't worry. Today, we're giving you the keys to crack it. And we're going to start with the most important part of any airport, the runway itself. Let's just zoom in on one part of that code. Every letter and number you see here is a critical instruction telling a pilot exactly how to land. It covers everything from the lighting system to the precise angle of their approach, and even the PAPI. That's the Precision Approach Path Indicator, which is basically a fancy set of lights next to the runway that tells a pilot if they're coming in too high or too low. Okay, let's start with TCH. This isn't just random jargon. It's about precision down to the foot. The threshold is just the very beginning of the runway pavement. So the TCH tells a pilot exactly how high their wheels need to be at that exact moment they fly over the edge. And here's why that matters so much. Hitting that 70-foot mark is the key to a smooth, safe touchdown. It makes sure the plane touches down in exactly the right spot, with tons of runway left over to slow down safely. And you know those lights you see out the window when you're landing? Let's decode those. ALSF2 refers to the super bright, flashing lights, they call them the rabbit, that race toward the runway to guide the pilot's eyes. And TDZL? Those are the rows of lights that are actually built into the runway, marking the perfect spot to touch down. And what's really amazing is that this language is universal. A pilot from anywhere on the planet knows exactly what these codes mean. And just when you think it can't get any more detailed, it does. See, it's not as simple as just knowing how long a runway is. Get this, the exact same strip of concrete can actually have 4 different official lengths. It all depends on what the pilot needs to do, whether they're taking off, landing, or planning for an emergency stop. Check this out for runway 27R. The distance for takeoff is a whopping 12,390 feet. But look at the landing distance available, the LDA. It's 500 feet shorter. So what gives? Well, our manual tells us the threshold is displaced. That just means pilots can't land on that first 500 feet of pavement, which gives them a clear path over any obstacles on the approach. Okay, so the plane has landed. Phew, right? Well, the game is not over, not even close. Once a plane is on the ground, a whole new set of rules kicks in. The dance on the taxiways is just as complex as the one in the air. Let's see how that works. Think of the airport as a city, but for planes. And this manual, it's the traffic code. And it's designed to prevent, well, colossal multi-million-dollar fender benders between giants. These rules lay out exactly who can go where, how fast they can move, and who has the right of way. And it's all based on the sheer size of the plane. But why that specific number, 214 feet? It feels a little random, right? Well, it's not. Take a Boeing 747, for example. Its wingspan is, you guessed it, about 214 feet. These rules are the precise choreography that allows the world's biggest jets to navigate the airport without their wingtips getting a little too close for comfort. All right, so we've seen the written code, but how does all of this translate into the spoken language of aviation? It's all about radio frequencies, a constant, carefully managed stream of communication that guides every single movement. An arriving pilot is on a kind of digital journey, seamlessly handed off from one controller to the next. Think of it like a relay race. Each stage of the flight, from miles out all the way to pulling into the gate, has its own dedicated controller and a unique radio frequency. It's a chain of command that never, ever breaks. And while a lot of this has been voice communication, we're seeing more and more of it switch to digital data links to make these handoffs even faster and safer. So now that we've learned the language, let's go all the way back to where we started. That block of text that looked so confusing, well, now it tells a story. Remember this? It's not so intimidating anymore, is it? You know ALSF2 is the lighting system. You know TCH 70 feet is the key to a perfect touchdown. You can even see that RVR note, which tells pilots how the runway visibility is being measured. And you know that 500-foot displaced threshold on runway 27R changes exactly how a pilot can land. You can now read the language of the airport. When you really get down to it,
Every single cryptic line in this document represents decades of experience, of engineering, and of planning. It is all focused on one single goal: getting you and millions of other passengers from point A to point B as safely as humanly possible. What you've just done is decode the hidden operating system for one of the planet's most complex hubs. And it kind of makes you wonder, right? What other secret languages are all around us, written in manuals just like this one, all quietly keeping our very complex world in motion?